Question number 138. Right. To solve question number 138, let's see. Find the area of triangle ABC if its vertices are A, B, and C. Now, we have 3 points on a triangle, right? So we've got the vertices 2, 1, which is A. It's not actually on the x-axis, just a little bit raised. B, which is minus 3, 7, and C, which is minus 4, 5. Now, directly opposite B is B, A is here, and C is here. Now we have, first thing we have to go and find what is, because these angles are not given. So remember, these angles are not given, neither angle C is given, nor angle B is given. Now, if we have to go and find, the area of this triangle, we need to go and find the lengths of all the sides. So A is the same thing as saying BC, which is equal to square root of this, is equal to the square root of minus 3 plus 4 all squared plus 7 minus 5 all squared. So what we have here is 1 plus 4, which is square root of 5. For B, which is AC. AC is given by the square root of minus 4 minus 2 all squared plus 5 minus 1 all squared, which is equal to square root of 36 plus 16, which is square root of 52, and square root of 52 is 4 times 13, so 2 root 13. Can be simplified as 2 root 13. And then C is equal to AB, which is equal to the square root of minus 3 minus 2 all squared plus 7 minus 1 all squared, which is equal to square root of 25 plus 36, which is equal to the square root of 61. Now, to solve, now we have the lengths of all the sides. We can find angle A. Remember, the area formula is area is equal to half BC sine of angle A. Now, to find the sine of angle, we can't actually find angle A, so we need a representation for sine of angle A. And to find sine of angle, we can get cos of angle A, which is equal to minus A squared, B squared plus C squared divided by 2BC, which is the cosine rule. Now, we can get a representation for cos of angle A. Then what we can say here, this is equal to, what is B squared plus C squared? B squared plus C squared, B squared is 52. C squared, we can see from above, is square root of 61 all squared, 61, minus A squared. A squared is 5 divided by 2 times B times C, 2 times B, which is 2 root 13, and C is square root of 61. Now, what we can see here is we have 100. If we add up these, 52 plus 5, which is sorry, 52 minus 5. So we have 57 plus 61. That gives me 8. That gives me 11. Sorry, this here should be 47. Something wrong, right? So 52 plus 61 minus 5. 52 minus 5 is 47 plus 61. We're getting 108. And then we take 108 divided by 4 root 13 root 61. 108 divided by 4 is now equal to half of 108. 108 divided by 4, we should get 27 over root 13 root 61. Now that is cos of A. So what is sine of A? Let me just write it out. Sine of A should draw a triangle. Why do we need sine of A? We need sine of A because we need to go and calculate area of the triangle, which represents a sine. So angle A here is 27. So we have root 13 root 61. And we need to find this. So area, therefore, area is equal to half BC. BC is square root of 52, square root of 61. Square root of 52 was 2 root 13, square root of 61. And then sine of A is equal to opposite, which is the square root of this here squared, which is 13 times 61 minus 27 squared, which is, we need to calculate this, over, so we have opposite over hypotenuse, which is square root of 13 times square root of 61. Now you can see that square root of 13 and root 13 cancel out, square root of 61 and square root of 61 cancel out, the 2 and the 2 cancel out. So the area is equal to square root of 13 times 61 minus 27 squared. So 13 times 61 is equal to, let's work it out in the side. 13 into 60 plus 1. 13 times 6 is 13 times 5 is 65, 78, 780 plus 13, we should get 793. And 27 squared, looking at 30 minus 3 squared, which is 900, minus 3 times 2 times 30, 90 times 280 plus 9, that should give you, okay, 900 minus 180 should give you 720, 729. Let me subtract these two. So you can say 13 minus 9, that should be an 8. 8 minus 2 is 6. 13 minus 9 is 4. Therefore, area is equal to the square root of 64, which is equal to 8 units squared. Or an alternative method would be to use the Heron's formula. So what's Heron's formula? Heron's formula says A is equal to square root of S into S minus A, S minus B into S minus C, where S is equal to A plus B plus C all over 2. Now let us go and modify this formula. So let us modify. Right. So I'm going to write down area is equal to just changing the color of the pen. So you can write down these things. What's S? S is A plus, let us look at, simplify this inside the square root. What is this simplified as? So we have A plus B plus C over 2 times A plus B plus C over 2 minus 2A over 2. Then A plus B plus C over 2 minus 2B over 2. Into A plus B plus C over 2 minus 2C over 2, which can be simplified as 1 over 16 into A plus B plus C into, let's look at, so collecting this term, remember all the denominators are out because this is still over 2. This is still over 2 and that's still over 2. 2 times 2, 2 times 2 times 2 is 16. So 1 over 16, A plus B plus C, this is the term. And let's look at A plus B minus C. So we should be looking at that term. So A plus B minus C. So we can look at difference of two squares into, let us collect these two terms now, these two terms. So what we have here is minus A plus B plus C. And then what we have here is A minus B plus C. But what's common in both is that plus C here and plus C here. So we can write it out as 1 over 16 into A plus B all squared minus C squared. That's what this part here is. Into, let's look at this. This can be written as C minus A minus B into C plus A minus B. Now, simplifying this should give me 1 over 16 into A plus B all squared minus C squared into C squared minus A minus B all squared. Therefore, Heron's formula simplifies to, remember, we still need to take the square root of this entire thing here. If we do take the square root of this entire thing here, we will get quarter square root of A plus B squared minus C squared into C squared minus A minus B squared. Now, let us apply this formula here. So what we can say here is that quarter into, let me just write this to the power half, which is same as the square root of. So what we have is A plus B minus A plus B all squared minus C squared. So what's A plus B? A is the square root of 5. B was 2 root 13 squared minus C squared, which is C squared was square root of 61. Yes, square root of 61. So 61 into C squared, which is 61 minus root 5 minus 2 root 13 squared. So what we have is quarter into, let us open this part. So in two brackets like this to the power half. So we have 5 minus 4, root 13 times root 5 is square root of 65, the plus there, plus 4 times squaring this, 4 times 13 will give me 52 minus 61. 61 minus, I'm opening this entire thing up here, minus 5, minus this will become a plus 4 times 5, sorry, root 13 times root 5 is root 65, so 4 root 65 plus 4 times, not plus, should be minus 4 times, should be minus 4 times, that's a 65, minus 4 times, minus 4 times 13 minus 52. So what we have here is quarter into, now 5 plus 52. 5 plus 52 will give me 50. So 5 plus 52, which is 57, minus 61, which is minus 4, plus 4 root 65. And then 61 minus 5 minus 52. So 61 minus 5 minus 52 is minus 57. 61 minus 57 is 4, plus 4 root 65, all to the power half. What we can say is quarter into, we don't need this. Okay, quarter into, let's take out a 4 from here and rearrange. 4 into square root of 65 minus 1, and take out another 4 here, into root 65 plus 1, all to the power half. Now we can write it as quarter into square root of 4 times 4 is 16, into square root of 65 minus 1. 65 plus 1 is 65 minus 1, which is 64. Now now surely you can see the answer, which is equal to square root of 16 is 4. So quarter times 4, square root of 64, which is equal to square root of 64, which is 8 units squared.